Hi. So in WebRtc, we have often seen the use of stern and turn servers. So in this video, we will discuss why we need stern and turn servers in WebRtc. So to first know that, we have to first discuss about what is NAT. So NAT is a short form of Network Address Translation. So basically, 90% of devices are behind a NAT these days. So what happens is, like for this device, it is connected to this router, and this router has provided this device a private IP address. That is this one. So whenever this device wants to get data from a server on the web, it will somehow send a request to the router saying that this is my private IP address and I want to get a response from this server. But this router cannot allow this response to go to the outer side world directly, because no one will identify this private IP address. So what it does is, it creates a table where it assigns a external IP and external port to this internal IP and internal port, and it also changes the request that it got from the internal device, and then it sends the data to the web. And when we get the data back, it uses this table and sends the data to this internal IP internal port, which is mapped with this external IP and external port. This is how NAT works. So there are four different kinds of NAT. The first three covers 90% of devices connected on the web. The first one being the best for WebRtc, the fourth one is the worst for WebRtc. We'll see that in a minute. So let's discuss the first one. The first one is one-to-one NAT. It is also called the fully connected NAT. So what it does is, whenever it gets a response, it directly sends the response to the internal IP internal port, which is assigned with the external IP and external port that it got the response on. In this slide, we can see that for the first one, we have got a response on this external IP and this external port. So it is already assigned to an internal IP internal port, so it will pass that. Also for the second one, it will pass that. Also for the third one, it will pass that, and for the fourth one being, it will also pass that. So this is how one-to-one NAT works. Let's see how address restricted NAT works. Right. So address restricted NAT, what it will do is, it will first check whether we have already connected to the destination IP before with the external IP before or not. So in the next example, we can see that for the first one, yeah, we have already connected to a destination IP of 4.4.4.4 and on port 80. Yeah, we already have connected there, so it will pass that. For the second one, we have already connected to this destination IP, but not in this port. But in the address restricted NAT, it will not check the port; it will just check the IP. So we have connected to this IP, so it will pass it. Or the third one, it will pass it. But for the fourth one, it will not pass it, because we have never connected to this IP address, as we can see in this NAT table. So the fourth one will not be passed by the router. And the third one is port restricted NAT. So it is basically the extension of the address restricted NAT. So it basically checks both the destination IP and destination port. So in this example, we can see that for the first one, yeah, we have already connected on this 4.4.4.4 on port 80, so it will pass that. But for the second one, we have connected to the destination IP, but not on this port, so it will cancel that. For the third one, yeah, we have connected on the destination IP and on the same port, so yeah, it will pass also. It will also pass that. But for the third one, we have never connected even on the destination IP, so it will fail that. As you can see, the fourth type of NAT is symmetric NAT. So what it basically checks is, it will check whether we have connected to an destination IP on the destination port with a specific external IP and external port. All things should be same. So in this example, we can see that for the first one, yeah, we have connected to the destination IP on this port from this external IP from this port. Yeah, we have connected that, so it will pass that. But for the remaining three, we have never connected to the same from the same external IP from the same external port, or the same destination IP or the same destination port. So it will not pass the remaining three. So now let's discuss what is stern server. So stern basically means session traversal utilities for NAT. So it basically tells us our public IP address. So it basically gets a request from us and packs the data of our external IP and external port and send this back to us. Stern servers are often cheap to maintain, so we can find a lot of free stern servers on the web. So how stern server works is, what it will do, that we will send a request to the stern servers, and we will ask that, hey, who I am. So what stern server will do is, it will pack the our external IP and external port to a response and send us back that as a data. So and we will be then knowing the external IP and external port. Without a stern server, we can never know our external IP and external port when we are connected to NAT, because the router cuts this external IP and external port when it sends the response back to the private IP addresses. So let's see how stern when it works. So this laptop or device is behind a fully connected NAT, and this is also behind fully connected NAT. So it will connect to the stern server and will say, hey, who I am. So it will say that you are this, or this public IP, your public IP address this, and you are on port this. It will also ask that same thing, and then it will say, hey, hello, I am this, and I want to connect to you. So it will be okay, sure, connect to that, because we know that in case of one-to-one NAT, every data gets passed if if the public IP address is actually assigned to a private IP address. So it will be connected. And in case of address restricted NAT and port restricted NAT, we have to somehow send a package between them, so we can connect between them. But in case of symmetric NAT, what happens in this case? So this device is connected behind a symmetric NAT. So in this case, what it will happen is, whenever we say, hey, I am hey, this, I am this, and let's connect. So it will say, yeah, I am this, okay. But I never known you. I have created this public IP address for this server only. So I don't know you. So it will not pass that. So it will, no, I will not connect to you. So now in this case, turn plays the role. So what turn is? Turn is the short form for traversal using relays around NAT. So in case of symmetric NAT, we use turn. It's just a server that relies on packets, and it's actually expensive to maintain and run turn then stern. We'll see that in a minute. So what a turn server will do is, whenever this device is behind a symmetric NAT and this device is also behind a symmetric NAT, so turn will act as a mediator between these devices. So these devices will connect to the turn server. It will send a request, and then it will get the request back. So and as this request will go through the router, so the NAT table will have the same IP addresses on the register. So these devices can actually connect to this server. So it will say that, hey, hello, I am this, say hello to this IP address. So the turn server then call, hey, this IP address said hello to you. Then this device says, sure, send him hi to. So then this turn server will tell, hey, this public IP address had said hi to. This is how turn works. In this example, we have shown how messages goes through turn, but we can also send a stream of data through turn servers. But all these turn server, how to know when to use what? Like when to use a turn server, when to use a stern server. So that is where ICE plays the role. So ICE is interactive connectivity establishment. So what it does is, ICE collects all the available candidates, the local IP addresses, reflexes, turns was everything, and it will then send. Then it will choose the best one and send the data to the remote peer via session description protocol, or SDP. Now we will see what SDP is. So SDP is basically session description protocol. Which is full from? The main goal of SDP is to send the data generated by a user to the other users somehow. So it basically a format that describes the ICE candidates, networking option, media option, security option, and other stuff. It not really a protocol; it's a format that we use in WebRtc. So this was the explanation that why we use a stern and turn servers in WebRtc and why we need it.